everybody, welcome back to the channel. So today this is my second try recording this video. So today we're going to be talking about quadratics. If you have already watched my last video about them, I'd highly recommend you doing that because you might want to know that before jumping into this video. So today we're going to be talking about quadratics, and so the first thing we're going to be discussing is proving that ax squared plus bx plus c equals 0 formula, and also equation and we're also going to prove the quadratic formula. Okay, so the first thing is that, so when I have, this is something you might want to know because this is actually very important into how we're going to be proving the equation today. So we can simplify this, of course, into making this into simpler terms, right? What we can do is we can put it in such terms like this, because we're multiplying this twice, so we can just expand it and put it into terms like that. Then we can use FOIL to distribute this, so we can use that and then that. So then this will turn into A plus B, because we're multiplying A times A and then we're multiplying A times B. Same thing with this one. We can do B times A and then plus B times B itself. So that means you have to add that plus that, which will turn into that. So then after doing that, we can simplify this even more using the derivative property. So this will turn into this right here, turns into a squared. Sorry, that doesn't look like an a square at all. Whoops. It turns into a squared plus ab plus ba plus b squared. Now, if you notice here, these are like terms because AB and BA, same thing. So that can be simplified into a squared plus b squared plus 2ab. So something to know is that equals that. So that means after simplifying, this equals that. So that's something to know because we'll be using this information to prove the formula, equation, So whenever proving the equation, we always start off with the equation alone, right? Ax squared plus bx plus c equals 0. Easy and done, right? Now, when we want to get into terms like this, we can notice that x squared can be used as a squared. Okay, so then we're just going to divide by a. So when we divide by a, x squared is alone, plus bx over a, is dividing this by a, plus c over a, and that also equals 0 alone. Now we want to get, if you notice here, we have 2ab, so we're multiplying 2 times a variable times a variable. So that means we can change this up. X squared plus 2 times x times b over 2a, because we're multiplying 2, but whenever multiplying 2x, we have to divide by 2a to get that equal that. Plus CA. Now here's where something a little tricky comes in. It's not that hard when you know what to do. So x squared plus 2x over b over 2a. If you notice here, we have a squared, and then we have 2ab right here. Now we want b squared alone, right? We want b squared right here. So whenever we want b squared, we can add something. We can add b over 2a squared. But now if you notice something, if we have the CA here, this equation here would be greater by b over 2a squared. That's the problem, so we're just going to subtract b over 2a squared, and then we're going to add the CA. And then this alone equals 0 as well. Pretty long thing, but this matches what we have right here. Now, for that, we want to simplify this even more. This right here is a constant. It won't change at all because this is just 0, and then that is a constant. 0 over a doesn't change. Whenever we have x, we don't have a constant because in quadratics, x has 2 roots. And then, so that means this right here, that right there would be x plus b over 2a squared. Now if you notice something, if we look, we have a plus b squared, x plus b over 2a squared. These are the same terms. A is x, b is b over 2a, and then we also have that squared. This parentheses here is squared. And because of that, we can put this into those terms because we already have this put into that. Now let's go even further. So now we're going to be talking about graphs. Let's say we have a graph, and let's say we have a quadratic function that looks something like this. Right? We have this parabola. Now we already know how to find these two roots. Right? We put them in the formula. We know what A, B, and C are. We can just put that into the formula and get those two roots. However, we don't know what that is. Right? Now let's think here. The slope of this line right here, the slope of that would be 0 because it's flat. That's the minimum. Whenever that slope is 0, we can set this right here to equal 0. Now, something to note here is that since we have it squared, this can be 0 or any positive number. And since we want to get the lowest 0, this expression right here, x plus b over 2a, has to be equal to 0 because 0 squared is 0. So that means we can simply put actually something like that. X plus b over 2a equals 0. Because it's always going to equal 0. We have that squared. 0 squared is equal to 0. So that square doesn't really matter what we're having here now. Now, that doesn't look like an x. Now when we have this, we're trying to simplify this. We're trying to get x. We're trying to find this x when this equals 0. The slope equals 0. Now when we're trying to find x, we can subtract b over 2a. So that means in this right here, when the slope is 0 in the parabola, that means x would equal negative b over 2a. Because we just proved that right here. Now knowing that, that's a good thing to know because finding the minimum of quadratic functions is something rather important. Now we already proved the equation because we put this into those terms, right? And then we can put that into that terms, right? So that means after knowing this, what we can do here is let's prove the formula. Let's prove why these two roots when y is equal to 0 would work. And the reason why we set this to 0 is because y has to equal 0 in here to find the two roots. So whenever we want to prove roots, we need to prove the formula, right? And when proving the formula, we have to start somewhere because we have to use the equation, and then from there we have to prove the formula along. Right, so let me just erase this. Right, so let's take a look here. When proving the formula, we know that this squared. We know that this is 0. Now, as we proved in the equation, this has to equal b over 2a squared minus c over a to make sure that these equal another. Now, whenever we're trying to simplify the formula, we also want to get this x alone because the formula finds x for two roots. So whenever this is squared, we can turn this into a square root. Plus b over 2a equals plus or minus, because now we have two roots, the square root of b over 2a squared minus c over a, right? Now we're trying to get x alone, so we can subtract b over 2a equals negative b over 2a plus or minus the square root of b over 2a squared minus c over a. Correct? So, from here, we want to get these to collect denominators. So we can simplify this right here. And what we can do with that, right, b over 2a squared, what we can do with that is we can square each one. So b squared, so b times b b squared is just b squared. 2a squared. Whenever we're multiplying 2a times 2a, we'll get 4a squared. That means this can be simplified to such terms like b over 2a plus or minus square root of b squared minus 4a squared. And then, of course, minus ca. Now, we want to get to select the denominators, we can simplify this even more. Ca. When we're trying to get 4a squared, we want to multiply. So, what we can do is multiply 4a. So that means this underneath here will look like 4a squared. And then, since we multiply 4a on 4a, I have to do the same thing for c. So then this will turn into 4ac, right? That means this will be further simplified into negative b over 2a plus or minus the square root of b squared minus 4ac over 4a squared. Sorry, there is no squared. 4a squared. After that, we can simplify it. Knowing that 4a squared, whenever we square root that, that'll turn into 2a. What we can do here is set this to equal x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Now this is the exact same thing as the formula was what we have here. So that this right here, these steps will prove the formula and show why when y equals 0 we can find the two roots to find x, right? So now what we're going to be talking about here is proving something rather a little different. We're going to be proving another step of finding the two roots as well. So let's erase all this real quick. Right, so let's say we have a graph. Make this extra big. Right, and we have function that looks like that. This function here is f(x) equals x squared. That's our function. Now, whenever having a function, we can put in x. So let's just call this point x right here, right? And we can move up to this point right here, and then that point equals x squared because we're plugging in x in our function, and whenever we get x squared, right? Now, let's say we have another point here. We can move this up to here. This right here is called the change of x because we can add, so that means we can add x plus the change of x. Now, whenever we're doing this, we want to go up here, supplement that. So it means this turns into x plus change of x. But since this is our x right here, we're going to square that. So that means this whole thing is squared, right? So, after knowing that, and knowing that d over dx, x squared, equals 2x, right? Because we can just put this here and subtract them from the exponent. We're going to be proving this, and we're going to be showing why this equals that. So, after knowing that this equals that, what we can do here, so we can do here, so now knowing that whenever having this, we always want to start with the change of y over change of x, because that's how derivatives work, right? For finding something and stuff like that, right? So how can we put this into forms like that? So let's take a look here. So now let's take a look at the change of y. Now remember, the change of y is this line right here. That's the change of y. So now we want to put the change of y. So what we can do here is put this point squared and then minus x squared. Why are we doing that? Because the difference of this and that will get the change of y. Now after that, we can put this over the change of x, because change of x is just change of x, so that doesn't change at all, right? Now having that, now we want to simplify this as much you can go. Now if this already looks simplified, it's not, because we can easily simplify this into further terms. So let's see, take a look. let's take a look at this right here. Right? Knowing what we learned from simplifying that, what we can do is just do the same thing and just put it in those terms, right? Right? So then let's take a look here. So that means this turns into x plus change of x times same thing minus x squared over change of x alone. Now I'll simplify this even more using FOIL. What we can do here is then do x change of x plus x, sorry, a second. Yeah, so we can do x plus change of x plus change of x times x plus change of x minus x squared. You can't forget that, but that's actually pretty important. Over x, change of x. Switch markers here. Now, after knowing that, yeah, it works. After knowing that, we can simplify this even more using the distributive property. X times x is x squared plus x times change of x plus, so we just covered that term, this distributive property. Now we can do the same thing with this side. Change of x times x plus change of x squared. Okay, and also minus x squared. And then this over change of x. Now, what this equals, we have like terms here, so that's what just equal x squared plus 2x change of x plus change of x squared minus x squared over change of x. Right? Now, we're dividing change of x, so let's see. Change of x, this cancels out, and then this also cancels out. Not all of it, this just change of x squared, negative x squared cancel out. So that means all we're left now is 2x plus change of x. And you're wondering, this does not equal that. However, when we have change of x, the change of x, because we're using derivatives in this case, change of x gets so small that it practically is zero. So if the change of x when you're using derivatives, the change of x basically equals zero. That means 2x plus 0 is just 2x. Now when you're looking here, you just prove that this, how d over dx x squared equals 2x, we just simplified this whole thing, all these steps we did here, and we just put it into that. And when we're simplifying that, we just prove that d over dx x squared equals 2x using the steps we took. Right? So that is simply a way we can prove a simple function which is x squared into such terms. Now, so you guys saw this, we're going to be doing one last thing before I end the video. We're going to be showing how this food. Right? Okay, I just want to make sure I'm giving the right information. Okay, so knowing that after proving this equation, we know that it's true. However, we know that when we have this, we can just multiply that by x minus x2, and then this all equals 0. Now, what x1 and x2 are, those are the two roots which we just proved from the equation of, negative b plus or minus the square root of b squared minus 4ac over 2a. We can find these two roots from this formula we have here. And since this is a plus or minus, this right here, we have two roots. That means we need x1 and x2 to make this possible. Now, something to know before we get into this is that x1 equals negative b plus square root of b squared minus 4ac over 2a. And then x2, on the other hand, equals negative b minus b squared minus 4ac over 2a. And the reason why I'm changing these is because of the two roots we have right here. Right? Right. So now, we notice we have two here. We have two common variables. We can just divide a on each side to get x squared plus b x over a plus c over a equals x minus x1, and then multiply that by x minus x2. Right? Now, so we can simplify this using the a plus b squared. We can simplify this. So this actually will just equal x plus b x over a plus c over a equals, using what we have here, this will just equal, x squared plus, x squared minus x1, minus x2 plus x times 1 times x2. Now we can simplify this right here into such terms like x squared minus x minus negative x, and then plus these terms, and then of course plus x1 times x2. Now, after knowing that that equals that, we want to prove two things into showing why this equation equals that. So what we need to prove is that this equals the b over a, and then we also need to prove that x1 times x2 equals the c over a. And to make sure that this would equal that. So let's start with number 1. This is number 1, this is number 2. Number 1, let me erase this real quick. Now, when knowing this, we can simply put that to x1 plus x2 equals negative b over 2a. Plus, and I'm writing here, just writing the equation in this different terms because this will be more important later. Now this is the first root, x1. Now we have to replicate that onto another root, so that means the same thing. And so we're just going to subtract. Right, if you notice your negative, that positive cancel out. All we're left with is x1 plus x2 equals negative b over 2a minus b over 2a. Oh, we're not having this. Yes, this equals x1 plus x2 equals negative b over a. Right? So that means we just proved that this negative equals b over a. We just have it in different terms. If we multiply negative 1 on each side, it would get the same thing, just equals b over a. So we just prove that what we have there is true. Now, let's prove the next thing what we have on the list. Now the next thing is just showing that how x1 times x2 does indeed equal c over a. Right? So in having that, all we want to do, well, first thing we need to know is that, this is something you might also want to know, equals a squared minus b squared. So we're going to put that into that terms, right? So x1 times x2 equals, now we're going to be multiplying these two roots, plus square root b squared minus 4ac. We can also put in this term as well, something a little different. And then after that, with that multiplied by same thing. And so we're going to be subtracting because we have two different roots. Right? Now after that, knowing how that equals that, we can do here, since we have two square roots, that means x1 times x2 would have to equal b squared 4a squared, because we have 2, minus b squared minus 4ac 4a squared. Why this? Because we're multiplying this times that, which is, the same thing. Then after that, we can simplify this into even more terms, which is x2 equals b squared minus b squared plus 4ac over 4a squared. Right? Cancel out. After that, all we're left with is x1 times x2 equals 4ac over 4a squared. When we divide 4a on each side, all we're left with is that x1 times x2 equals c over a. And that right there, simply put, is just what we're trying to prove, how x1 times x2 does equal 0, right? Anyway, that's all we're going to be discussing in this video. I hope you enjoyed the video. I hope you enjoyed this video, and thank you guys for watching, and I hope you learned something new.